MAN Diesel and Turbo manufactures tailor-made integrally geared compressors, also known as multi-shaft compressors. A modular design concept can be used for these machines, and all components come with extremely good references. Up to 8 compressor stages are arranged around a gear unit in the same way as the hands of a clock. The basic principle is the same in that only one drive unit is needed to rotate them at different speeds. This compressor has 6 stages, arranged in 2 sections. Downstream of the second stage, the customer can draw off a specific volume at medium pressure. The remainder is further compressed to the desired discharge pressure by the second section consisting of stages 3 to 6. Each stage contains an impeller, and each pair of stages with the same impeller speed is arranged opposite each other. They share a pinion shaft, at the ends of which the impellers are attached. Inlet guide vanes are mounted in front of the first stage of each section, here stages 1 and 3. Their blades can be adjusted synchronously, which enables each section to be controlled individually. Each pinion shaft meshes in the bowl gear with its central teeth. The pinions have varying numbers of teeth, which gives different gear ratios depending on the particular pinion and enables optimal speeds for the 2 individual compressor stages. It's the impellers, gear unit, and bearings that largely determine the efficiency and service life of an integrally geared compressor. And with MAN Diesel and Turbo, the design of all components and the related know-how come from one source. Whether dry or humid air, refrigerant, nitrogen, carbon monoxide, or dioxide, the rotating impeller sucks the respective process gas through the inlet guide vane unit. Centrifugal force works here in the same way as with a roundabout and accelerates the gas radially in the blade channels, that is to say from inside to outside. This provides the gas with kinetic energy, which is transformed into pressure energy in the impeller and diffuser. The volute then collects the gas. With each compression, the gas temperature rises. This in turn somewhat reduces the density and increases the volume. Because this means that the following compression process would then require more energy, the gas flows after each stage through piping to an intercooler that reduces the gas temperature before the gas enters the next stage. The shown process, axial flow to the stage, compression, and transfer to the intercooler, repeats itself stage by stage. This raises the pressure incrementally. Depending on the unit size, it can compress up to 350,000 cubic meters per hour to a discharge pressure of maximum 250 bar. Integrally geared compressors have significantly higher efficiency levels compared to multi-stage single-shaft compressors with the same operating speed. They can not only be used on their own. The one shown here, driven by a steam turbine and supplied with pre-compressed air by a main air compressor, is used particularly in air separation plants. They generate large volumes of oxygen, for instance for coal to liquid plants. Beside the integrally geared compressor, MAN Diesel and Turbo can supply process piping and process gas coolers, the complete train oil system, or as well the complete machine train from perfectly coordinated components. The Berlin site has developed and built integrally geared compressors since 1977. Worldwide, hundreds of units reliably compress a huge variety of processed gases daily at high efficiency levels and discharge pressures. Their modular construction principle enables them to be designed and supplied for the most varied customer processes.